Welcome back. Now, probably a lot of you have heard about denial of service attacks. They're one of the biggest threats in the last few decades, and they are widely being used as means of attacks even today. But first of all, let's talk about what even are denial of service attacks. You will usually encounter two definitions: denial of service attacks and distributed denial of service attacks. Both of these are malicious attempts to disrupt the normal functioning of a targeted server, a service, or network by overwhelming it with a flood or internet traffic. The primary goal of these attacks is to make a service or resource unavailable to its intended users, which can cause significant operational disruptions and financial losses. Now, when it comes to regular denial of service attack, a denial of service attack is typically executed by a single machine or connection. The attacker floods the target with excessive requests or data, which overwhelms the target's resources, making it impossible for legitimate users to access the service. On the other hand, we have a distributed denial of service attack. A distributed denial of service attack, or a DDoS attack, is a more sophisticated variant where multiple compromised systems are used to launch the attack. Now, in cybersecurity, you will usually hear compromised systems being also called a botnet. Now, this distributed nature makes DDoS attacks harder to defend against and more impactful as the attack traffic comes from various sources, making it challenging to distinguish malicious traffic from legitimate traffic. So, now that we know the basics, why exactly are they dangerous? Well, DOS and DDoS attacks are dangerous because they can cause expensive harm to businesses and organizations. Some of the potential impacts would include service disruption, operational cost, and security risk. When it comes to service disruption, we already mentioned, essential online services and websites can become unreachable, which can lead to loss of revenue, customer dissatisfaction, and damage to the organization's reputation. And all of this can be done with a single denial of service attack. Operational costs is also something that makes sense, as mitigating an attack can be expensive, requiring significant resources for both technical measures and potential downtime. And when it comes to security risks, during the chaos of an attack, other malicious activities might go unnoticed, such as data breaches or system intrusions. But when it comes to denial of service attacks and the people that conduct these attacks, what do they usually target? Well, their usual targets are web servers, since overloading a web server can take down websites, impacting e-commerce, impacting social media, and they can pretty much take any online presence down. When it comes to network infrastructure, denial of service attacks can target network components like routers and switches, and that can affect all the connected services and devices on that network. For specific applications, an attack can target the backend systems, affecting functionalities critical to business operations. And another important thing that we want to memorize are types of denial of service, or types of distributed denial of service attacks. First, we have a SYN flood denial of service attack. This exploits the TCP handshake process by sending a flood of SYN requests with spoofed IP addresses. The target server is left with half-open connections, eventually running out of resources and becoming unresponsive. Now, here's how SYN flood attack works. The client will send a SYN packet to the server requesting to establish a connection. When it comes to SYN ACK, which is the second response, that is where the server responds with a SYN ACK packet to confirm receipt of the request and to notify the client that it is ready for communication. Now, lastly, in a normal communication, the client is supposed to reply with an ACK packet, completing the handshake and fully establishing the connection. But that is not the case in a SYN flood attack. In a SYN flood attack, the attacker sends a large number of SYN packets but never completes the handshake by sending the ACK packet. This causes the server to hold the half-open connections in memory, consuming resources and eventually preventing legitimate connections from being established. Another form of denial of service attack is HTTP flood. This involves sending a high volume of HTTP requests to a web server, overwhelming it by consuming its resources. Now, unlike other attacks, it doesn't require sending malicious payloads, making it harder to distinguish from legitimate traffic. In an HTTP flood attack, we have flood of requests where the attacker sends a bunch of HTTP requests to the server, often through GET or POST methods. This ends up exhausting all the resources, as each HTTP request may ask for pages, files, or execute complex server-side scripts, overloading the server's resources. And these HTTP flood requests could mimic normal traffic, making it quite difficult to distinguish them from genuine user activity. Now, of course, it can be distinguished in a way that when HTTP flood attack takes place, there will be significantly more requests than usual. Now, some of the key differences from SYN flood attack and HTTP flood attack is that SYN flood is the attack that focuses on exploiting the TCP handshake by not completing it, and HTTP flood is where the attack occurs at the application layer, exploiting the web server by sending a large number of valid-looking HTTP requests to challenge its processing capacity. Right? So those are the two main differences between these attacks. Now, of course, besides these two, there are others, such as, for example, UDP flood, which targets the UDP protocol by sending a large number of UDP packets to random ports on the target server. The server attempts to process these packets, leading to resource exhaustion and network congestion. Also, ICMP flood is utilizing ICMP echo request packets or pings to flood the target. This consumes both bandwidth and processing resources, causing a denial of service. You might have also heard about NTP and DNS amplification. NTP amplification exploits Network Time Protocol or NTP servers to amplify attack traffic. The attacker sends a small query to an NTP server, which responds with a much larger response to the target and ends up overwhelming it. Now, similar to NTP amplification, DNS amplification leverages DNS servers to flood the target with large DNS responses. The attacker sends a small query with a spoofed IP address, and the DNS server responds with a large reply, amplifying the attack. And lastly, let us talk about prevention methods of denial of service or distributed denial of service attacks. It can involve a combination of different strategies. One of those is rate limiting. Now, implementing limits on the number of requests a server will handle from a single IP address in a given time frame is crucial when protecting against regular denial of service attacks. Also, implementing web application firewalls is crucial in order to filter and block malicious traffic based on known attack patterns. Traffic analysis is employing systems to monitor and analyze traffic patterns in order to identify and block unusual spikes or anomalies. And you can also implement distributed denial of service protection services. This is leveraging specialized services that absorb and mitigate attack traffic before it actually reaches the target. And two more terms or prevention methods that you might have heard about if you're coming from network background are load balancing and redundancy. Load balancing is simply just distributing traffic across multiple servers to prevent any single server from becoming overwhelmed. And redundancy is just creating redundant network and server architectures to ensure service availability even during an attack. Alright, so these would be the prevention methods. We now know what denial of service attack is, how it works, which types of denial of service attacks exist, and how we can prevent against